Okay, today we're going to talk about geometric means, and these occur within right triangles only. What it does, if I have this big right triangle right here, and I draw, if you remember vocab-wise, an altitude, this is an altitude from this vertex of the right angle. Here's the right angle for the big triangle. If I draw the altitude from that, which means it goes from there to the perpendicular of the opposite side right here, it splits this big triangle into two smaller similar triangles. Okay, so we have this small triangle, this medium-sized triangle, and the large triangle. All three are similar triangles. It only occurs when this altitude is created from the 90-degree angle within a right triangle to begin with. Okay, uh, so they might ask you to write the um, similarity statement between each of the three, the small, medium, large. What you could do is start from the right angles of each. For example, if I talk about the small triangle, start at this right angle. Remember this right angle on this side as well. Okay, so I'm talking the small triangle. I go right from the right angle out along the smaller segment. Remember, here's the smaller leg. Here would be the longer leg. So from the right angle out the smaller one. So it would be, we'd have to have a letter here. We don't have a letter here right now. So I couldn't write out a statement for you, but you will do this in your assignment itself. But go from here out along the short one and then along the hypotenuse. Well, then I need to go the exact same way when I do the medium. So from here, starting on this medium one, from the right angle, out along the smaller one, then along the hypotenuse. And then for the big one, start the right angle, go along the smaller one, and then out along the hypotenuse. And so you'd have that letter, and that letter, just to make sure that they stay in corresponding order. That'd be an example. You don't have to go from the right to the smaller as long as you do in the same order. Like go right longer hypotenuse. And from this would be right longer hypotenuse. And for the big one, be right longer hypotenuse, for example, and name the points of the triangle in that order. That's fine too. Okay. For this assignment, you're not focused on that. You'll have like one problem to do from that or two, but the main point you want to learn is how to calculate these lengths here. Okay, so uh, before we come up with these and explain how these come about, if you remember from middle school, you had a means extremes property, and it looked like this. Okay, the means are these two. That's why I have them written out here, right here, and the extremes are these two spots. So you have the means extremes property. So we know since these are two ratios set equal to each other, it's a proportion. It's called a proportion then, two ratios set equal to each other. We cross multiply. And so when we do that, we would get AD equals BC, which I have down here. So one of the questions I'll also ask you is, what if they switch the order? Well, I always have to come out with AD equaling BC. So say they're going to give you a blank in one of these spots, or possibly in two of these spots. So let's just say they give you BA, B over A only, and they put blank over blank right here. Well, I know from this answer up here, when I cross multiply, I have to get BC. So B's here, C must go there. And then when I cross multiply this way, I must get AD. So if they gave me A there, D has to go right there. Okay, so that's how I can know how to fill it in. You'll have this on your assignment, this piece. Okay, but just know from my original proportion they give you, when you cross multiply, you always have to end up with that answer each time, no matter what. Here, what they did on this one, they did the numerator plus the denominator over the denominator, A plus B over B, and then C plus D over D. Okay, you might not think these are the same as this right here, but let's cross multiply. When I cross multiply, remember I had parentheses around that, so I had to distribute the D through there, and parentheses around the C plus D, and I have to distribute the B through there. So when I cross multiply, I get BC plus BD equals AD plus BD, well, which is written right here. Notice then I have a BD in both of them, so I can subtract off that BD from both sides with the subtraction property of equality, and I end up with AD equaling BC, exactly the same as I started with. Okay, so just know that when I cross multiply, no matter whatever situation I have to come back to my original cross multiplication, AD equaling BC. So you'll have some of those where you're filling in the blanks with the letters to make that come out to be true here. Okay, so now let's go back up to the more difficult stuff of finding. They're going to give you some of these numbers and you have to calculate the others. Okay, so up here, these three up here are your potential means. A, B, and C are the potential means. That means you're going to have one of these that you are solving for or given already. Not more than one, it'll just be one that you'll be looking for at a time that you'll fill in. And as notice that potential means, that means they go in the mean spot. Here's the mean spot. So notice I either have A as my means, or I have B as my means in this equation, proportion, or I have C as my means. That's it. These ones down here are never means. These down here, the D, E, and F, so E is that short segment, F is the long one, and D is the entire one, E plus F. Those are my potential extremes. Notice in purple, those are these three, two of these three each time. Okay, so you have one of either A, B, or C, just one of these. It's either A, B, or C. And then of the D, E, and F, you get two of those three. Okay, two of these three every time. Two different, it'll never be the same. Notice D, DF, EF, they're all different. So unlike the means where it's the same in both spots, it's never going to be the same for the extremes. And so the question is, how do you know which two of these three to go along with each one of these here? Very simple. It's a great drawing, so see it all. Okay. All right, so if we have A, if they're asking us to deal with A here, all I do is look down here. Which two of these three are touching right there? Segment F touches there. Segment E touches at its endpoint right there. So it has to be E and F. Okay. Notice D's endpoint's over here and this endpoint's over here. That endpoint does not touch right here. It's got to be one of the endpoints touching right there. So now let's say it's B. Okay, so it goes in the mean spot. So it's got to be two of these three. Well, the end of this E segment touches right there, and the end of the D segment touches right there. So E and D. Again, it doesn't matter if I put the E there and the D there. That doesn't matter. When I cross multiply, I get the same thing. Just as I could put the F up here and the E down here. When I cross multiply, I get the same thing. Again, you see that F, that segment ends right there and there. Neither of those two endpoints touch down here at the B, so it cannot be F associated with B. And then finally for C, same rule. Okay, which two touch right there? Obviously the end of F, that endpoint touches there, and the end of D touches right there. So F and D. Again, I could have put F there and D there. When I cross multiply, I get the same thing. So that's how you need to memorize um, which proportion to set up. Okay, so now let's go ahead and look at some examples. Okay, I've already written out the work here. That just saves me time. So having to type it out, it'd take a lot longer if I typed it all out as I was going along with it. So I'm just going to explain it to you, and then you have all your work right here. Okay, so notice the one is to solve for the x right here. Remember, x is a mean because the means are the ones that are not on the hypotenuse of the big triangle. The DE and F, remember, here's the big triangle, here's the right angle, so here's my hypotenuse. The extremes are on this hypotenuse. The 49 and the 58 is what they gave me. So 58 being the entire length. Well, if that's 49 and the whole thing is 58, 58 minus 49 is 9. So I know that this piece right here is 9. Okay? So, again, the extremes are on the hypotenuse. So that means this one, this one, and this one are the potential means. Well, obviously, we're solving for x right here. I go down here, which two segments touch right there? The 9 segment does and the 49. So again, my means is x right there, and my two extremes, 9 and 49. Again, it doesn't matter which one I put. I could put 49 there and 9 there. When I cross multiply, I get the same thing. So now we cross multiply to solve it. You get x squared equals 9 times 49. Notice, and this is what I want you doing, I don't ever multiply the two together. Okay, and get a bigger number because I have to reduce a radical with a lot larger number. That's a waste of time. So remember, now I got x squared. How do I get down to x? I must take the square root of both sides. So that's what I do here. I didn't show the square root on both sides, the big one. I did it, square root, and then I do the square root of each number here. Okay, it's much simpler than multiplying 49 times 9 and then having to reduce that larger number. So the square root of 9 is 3, and the square root of 49 is 7, and then I multiply 3 times 7 together, and I get 21. Okay, if I would have multiplied 49 times 9, I would have got 441, because 21 squared is 441, and then I have to take the square root, and that happens to come out nicely to 21. But it's not going to always come out that way. You're going to, as you see here, we get radicals in our answer. Okay, so it's much easier to deal with smaller numbers, so follow my example. All right, let's come over here. We got the same situation right here, except for this case, they gave me the two segments that touch right there. I didn't have to do the 58 minus 49 to get that 9. They've already given it to me here. So again, there's my means, goes in the means spot. My two extremes that touch right there, 4 and 25. Now this time, I could have left it as 4 times 25 and done the square root of each, and I would have got the right answer, but 4 times 25 is 100, and a lot of you can just do square root of 100 in your head and get 10. Okay, so I showed you can multiply and get a bigger number. When it comes out to a nice number like that you're familiar with, then it could be easier to just do the square root of 100 and get 10 that way. You didn't have to. You could add square root of 4 times square root of 25, and that'd be 2 times 5, and that'd also give you the 10. All right, number 3. So now our mean is down here. Remember, this one, and this one are our potential means. So they're asking us for this one. And then so it goes in the mean spot. And then what are my two extremes? The one that's touched right here, 49 touches here, and the whole segment touches there, 57. So it doesn't do me any good to put in the 8 right here because I'm not using that segment. That segment does not touch down here. I'm using these two. So again, I put them in the two extreme spots. The order doesn't matter. When I cross multiply, I get the same thing. Take the square root of each number. Okay, square root of 49 is 7. Square root of 57 does not break down. So my answer is 7 square root of 57. That's the exact answer. When you leave radicals in your answer, that's the exact answer. Now in the DCAS, it might ask you to round to the nearest tenth. Then I just put the whole thing in my calculator and just do the square root. I could have just done 49 times 57, got the answer and take the square root and round it to whatever decimal they wanted you to. But we are doing exact answer, so you're working on reducing your radicals here and giving exact answer. Because on the DCAS, they might do one of each. One with decimal around the nearest tenth or hundredth, and another one exact answer. So you do have to be able to work with radicals. We'll also be working with radicals as we come up in Module 2 here as well with right triangles. And we'll actually, before that, do radical worksheets. Okay. Again, you were taught this in Algebra 1, radicals, and reducing them as subtract, multiply, divide them. But I know a lot of you have forgotten, so we'll be doing a review day, at least one day, if not two, on radicals. All right, so here we have the same one again, this mean that we're looking for, so it goes in the mean spot, and again, it's the same two. Touches here, and this one touches here for the long one. Remember that extremes are always on the long hypotenuse for the big triangle here. So 100 and 192. Cross multiply, you get 100 times 92, 192. Take the square root of each. Square root of 100 is 10. And the square root of 192. Okay, that's not an easy one. One rule to know for 4, because that's our first perfect square we check. You know, you have calculators to check. I'm doing this by hand in my head. The rule for 4, if 4 goes in the last two digits, so does 4 divide into 92 evenly? Yes, it does. That means 4 will go into 192. So I divided by 4 in my head, and I got 4 times 48. Well, the square root of 4 is 2 times 10 is 20, so I have 20 times the square root of 48. But 48 also has a perfect square in it. 16 times 3 is 48. Now, if you didn't know that, you might have to start at 4 and go down to 4 times 12, and then break down the 12 again because there's a 4 and a 12. So the length it takes you just depends on how well you know your perfect squares and which ones you want to check. Okay, so I knew 16 times 3. That's this perfect square went into 48. And the square root of 16 is 4. 4 times 20 is 80, and the square root of 3 does not break down. So the final answer is 80 root 3. Okay, next one, notice here, and this comes right from, actually from your assignment. I picked this one off of here because this worksheet that I was looking at didn't have any examples like that, so I decided to take this one right off your worksheet. Okay, we're doing two of them, two extremes. Obviously, we only can do one at a time. Okay, you can't do two at a time. So we either do X first or Y first. Now notice they didn't give me, I wrote in this 20. I got that from doing 60, the whole length, minus that 40 gives me 20, so I can fill that in. Okay, so I did X first, so that's my mean. Remember, that's a potential mean, that's a mean, and that's a mean. These three up here, the ones on the hypotenuse, of the big triangle. These are my three potential extremes, 20, 40, and 60. Okay, so again, X, I use solve for X first. So that goes on my mean spot. The two segments that touch right there are the 20 and the 40. So I did 20 and 40. Okay, cross multiply, X squared equals 20. Notice what I did, I didn't write 40, I wrote 20 times 2. The reason I did that is because I want two, if there's ever two of the same number that go into it, I want to write it and break it down to like this. So now I have taking the square root of each, I get square root of 20 times square root of 20 times square root of 2. Okay, and the square root of 20 times the square root of 20 is 20. You should remember that from algebra 1. If I multiply a square root by itself, it just takes off the square root. I could waste my time and multiply the 20 times 20, get 400, put in your calculator, square root of 400 if you don't know your Pythagorean or your perfect squares, and the square root of 400 is 20. But just remember, square root of 20 times square root of 20, or square root of 5 times square root of 5 is 5, or square root of 10 times square root of 10 is 10. If I multiply any radicals together of the same number, all it does is take off the radical. Okay, so then I get 20 root 2. Okay, so now you see why I broke it down instead of going all the way up to 800 and having to break down 800. Take longer. Okay, be smart, learn the shortcuts. You might not have learned this shortcut from your Algebra 1 teacher, but now you're learning it. All right, the last type that you will see is a problem like this, and this has been on the DCAS as well. It says find the geometric mean of each pair of numbers. That means, notice this, find the geometric mean. It means the mean is what we don't know, the mean. So you put X in the mean spot, and then that's the two they give you, and this will always be the case. They'll always give you the two extremes, so 14 and 12. Again, the order doesn't matter. I could have put the 12 here and 14 here. When I cross multiply, I get the same thing. So I cross multiply, I get X squared equals 14 times 12. Again, I'm not multiplying the whole thing together. I want to break it down simpler. So I notice between 14 and 12, there's a 2 that's in common, isn't there? They both have a 2 in it. So I'm going to break each one down, dividing each by 2 and split up that way. So square root of 14 times square root of 12, there's a 2 in each one. So square root of 7 times square root of 2, that's the square root of 14. And there's a square root of 2 times square root of 6, that's the square root of 12. And so I just went over, square root of 2 times square root of 2 is 2. And then I multiply the two radicals left together. Square root of 7 times square root of 6 is square root of 42. Since the square root of 7 doesn't break down and the square root of 6 doesn't break down, they have nothing in common. That means the square root of 42 will not break down either. Okay, and there's your final answer. I could have put some radicals, better looking radicals on this. I forgot to do this last one. I know some going quicker here, so a little more sloppy than these ones over here. Okay, so that covers basically every type of problem you're going to see on your assignment on this. Okay, so again, refer back to these notes, print these out. Okay, if I don't have them printed out for you, use this right here. You need to memorize the situation. Remember, these are my means. They go in the mean spot. Same letter twice. The extremes are always on the hypotenuse of the large triangle. These three, you're picking two of the three, and I just pick the two that touch the endpoint of that mean. So that endpoint right there touches E and D. This endpoint right here touches E and F. This endpoint right here touches F and D. That's why those are the two extremes for each of those types of means right there. Okay, get that memorized. You will see one or two problems on the DCAS dealing with this. One probably being about setting up similar triangles, writing the similarity in proportion in a corresponding order. And another one of solving it like we did here. It'll either be this type where you fill in the blanks or doing one of these types of problems back here. And that ends it. 19 minutes basically.